This is lesson 9.2, and it's about parabolas. We've talked about parabolas before when we talked about quadratic equations. So some parabolas you've seen. So if it's an upward facing parabola or if it's a downward facing parabola, you've seen that before. The thing that's going to be new is that we're going to try a different equation, and also you're going to have right facing parabolas and left facing parabolas. Alright, so first we're going to talk about the parabolas that face up or down. And the general form for that is x squared equals 4py. So notice that the squared part, the squared variable, is first and it's by itself. If your equation is not like that, then we'll have to change it, and I'll show you an example of that in just a moment. We can solve to find out what p is, or we'll be able to tell really easily from the way the equation is. So basically, if this number over here is positive, then your parabola is going to be facing like this, and it will go through the origin. All of our parabolas are going to go through the origin. And if p is negative, or if this section is negative, then it's going to face down like this, and again still start at the origin. That point right there, the origin point, is called the vertex of our parabola. And there are two other things that we're going to graph along with this. One of them is called the focus, and the focus is a point that's inside the parabola that's not on the actual curve itself, but it actually is a very important thing. The focus is going to be directly the same distance from the vertex as this imaginary line down here. So this is called the focus, and I don't mean imaginary, I mean not visible. We put a little dotted line so you know, and this is called the directrix. The directrix I like to think of telling us which direction to graph, because the directrix never actually touches the parabola. So if the directrix is down here, then the parabola has to open up. And if the directrix were up here, then the parabola would have to open down. And on a downward facing parabola, we're going to have the focus in here also. Now the focus, once we find it and graph with it, is going to actually tell us how far to graph some points. So from the focus to the edge across here, we're going to go 2p in each direction. So I'm giving you a lot of information, but it's easier to see from an example. So let's try one of those. So here's my example. I have negative 1/2 x squared equals y. And like I said, the x squared part is supposed to be by itself. So I'm going to start off by multiplying both sides by negative 2 over 1. Negative 2 over 1. Because that's the reciprocal of negative 1/2, and it cancels everything out and leaves me with x squared equals negative 2y. Okay, the fact that this is negative automatically tells me that this is going to open downward. So it's going to open down. Now, some other things we can determine from this. This part right here, this is the 4p part. So if my 4p part is negative 2, then that means p itself is negative 2 divided by 4, which means p is going to be negative 1/2. So what does that tell us? Well, if we're going to graph this, we know all of these are going to be at a vertex that's the origin. So on all of these graphs, I'm going to start at 0, 0. I'm going to put my point at 0, 0. Then I'm going to go down about 1/2, and we'll say this is 1. So we'll put our focus about halfway down right here. And then if you multiply that p by 2, then that tells you how far to go in each direction. So ignore the positive or negative part of it. We just need to know the distance. So if we take 1/2 and we multiply that by 2, 1/2 times 2 is 1. So I'm going to go 1 unit in each direction. And then I'm going to connect my dots out here. And there's my parabola. Okay, so now our focus is, we've marked our focus. The only thing we're missing is the directrix. The directrix is the exact same distance, so since p was negative 1/2, If we go the opposite distance up here, so I'm going to put my 1 up here, go halfway, so that's where my directrix is going to be. And that's all we're going to graph. We're going to graph the parabola itself, we're going to graph the focus, and we're going to graph the directrix. And that is all we need. Alright, if things are changed a little bit, if instead of being x squared it's y squared, again this is our general form, we're still going to go through the origin. That hasn't changed. Still going to go through the origin. But if p is positive, our graph is going to go to the right. And if p is negative, our graph is going to go, not down. That wasn't very good. P is going to go to the left. And it's still, remember, going to go through the origin, even though I'm a bad drawer. Okay, so in this case where y is the variable that's squared, p is positive goes to the right, p is negative goes to the left. So that means our focus is going to be inside here. It's kind of like inside your eyeball. When light goes inside your eyeball and reverses out, it's kind of like your pupil. That may have just grossed you out. Alright, so then the directrix is going to be opposite of the focus, and it's supposed to be, this is that same distance, although my drawings are very bad. This is still the p distance, and the focus, I'll just move it out a little bit so it's better, it's still going to be p distance. So graphing this is going to be the same. We have the focus, the directrix, and the origin, and we're going to use 2p to determine how far to go in each direction. So let's try an example of that. This one, y squared equals negative 12x. The y squared, first of all, tells us it's either going to be right or left. And it doesn't have a number with it, so the number's over here, so we're already in general form. So that tells me that my 4p is equal to negative 12. So divide both sides by 4, and you get that p is negative 3. So our focus is going to be at negative 3, and our vertex is the origin, and so we also know since p is negative, this should open to the left. But what if you forget? Well, I just always start off with my vertex at the origin, and then we go negative 3 places, and then I can tell immediately, well, it has to open this way, because the focus has to be inside of the parabola. Alright, so 2p is going to be 6. So I'm going to go 6 units. 1, 2, 3, 4, 5, 6. I'm going to go 6 units this way and put a dot from the focus. Remember, we're starting at, let me do this again. We're going to start at the focus and then put my dot here. And then 6 units this way will be the other one. I hope that's a good distance. So if that's my 6, 5, 4, 3, 2, 1. Okay. So then once I have the origin and these 2 dots, all I have to do is connect them, and there's my parabola. And then if I go 3 units this direction, I can draw the invisible line, which is going to be my directrix. And that's all we need. We've got focus, origin, directrix, and we did a distance of 2p to figure out how wide to make our parabola. And that is how we do parabolas.